Welcome class to Chapter 8 in Lab 9, Queries. We're going to talk about both attribute and spatial queries, and we're also going to get into a little bit of definition queries. We have some practice with queries already, so we're just going to dive deeper into the concepts of queries. So what is a query? I like to think of a query as a question, so query question. You're taking specific data out of either a map or a table. And you could ask questions like which roads are paved, what water sources are near a road. Once on a storm chasing trip, I had to digitize, which you'll learn in GIS 33, all the unpaved roads so we can avoid them when we're out chasing storms. Now, a query layer is basically the result of a query. It's usually in SQL language, which we aren't going to. It's basically structured query language. We're not going to necessarily get into the details of the language. Just know that that's sort of working behind a lot of ArcGIS queries. So we look into spatial queries, basically stuff that comes out of the table. How many parcels have a value greater than 100,000? Here in Los Angeles, I'm sure a lot of them are much greater than 100,000. Or we could say a spatial query, like, is my house in a floodplain? I would definitely want to know that. So you can also think of it as you're selecting features that you're interested in. For example, let's say you open up the properties of a table and you want to know which aspen stands are from a forest vegetation layer. So you can query for that, and then using the table you can calculate statistics just on those features, those aspen stands from a forest vegetation layer. Here in the bottom left basically is what a query could look like. Perhaps your coverage type, COV_type, I'm assuming that would be what that field stands for, is only TAA. That must stand for aspen. That's just one example. You can also look at patterns. If you query for different information, then you can also look at different information spatially. And you can ask various questions. When you get more into GIS later on in the certificate or AA program, you will look at spatial statistics and you'll look at clusters and dispersion rates. That's going a little bit too in-depth, but queries is sort of a way to start that. Start looking at specific data spatially. And again, you can continue to query and extract more and more data out of it to further define your analysis, especially if your analysis is very specific, like this question in front of you. Are there any mature stands with large trees and open crowns? That's very specific. And see in the bottom right, we're using two fields. So we need to find, looks like, I don't know what L stands for, but tree size 96 maybe is L and density is A. So both of those conditions must be met in order for your data to be extracted. And you can kind of see, it might be hard, this is a selection, and the selection is that light blue color. That's the selection that you get when you use a select by location query. And like I said already, you can use spatial relationships, you can look at different geographies, like what fraction of my tree stands are intersected by roads, and again, you can calculate statistics from that. Now, we're not going to talk too much about this because it's actually quite rare, but you can do a query on a surface, on a raster query, as long as you have some kind of attribute field in your rasters. Sometimes rasters do not have usable attribute tables. That's one of the, if you remember back from a previous lecture, that's one of the pitfalls of rasters. Okay, so let's understand an attribute query using Venn diagrams. Let's say that T represents all students in a university. A is students from New York, B, geography majors, and C, English majors. Notice that T represents, of course, all of the university students. If you have A and B, that means we have students from New York that are geography majors. A and C are students from New York who are English majors. But we don't have overlap from C and B because we're assuming that everyone has just one major. So with these concepts, when we are creating an attribute query, sometimes you want to query from more than one field or more than one variable. Right now, what you have in front of you are just single criteria. Select students from T that are from New York. Well, I guess there is a little bit of overlap here because T represents the entire population, and then New York is represented by the A. It looks like an oval, yeah. And then we have you can do a whole separate query and select students that are geography majors. So the way you do this, when you're trying to select a specific piece of data, or you're using numeric data and you need to have data greater than or less than, we call that relational operators. So you have your equal sign, which is pretty easy to understand. You could also do not equal, something I don't do very often, but it's possible. And then greater than or greater and equal than, less than or greater than, less than or greater. So, I'm sorry, less than or equal. So again, these are relational operators, and they also work with Boolean operators, which we'll talk about in a second. So going back to this, let's do a double criteria. So instead of just selecting geography students or selecting students from New York, we can say select students from T, that's our original database, okay, that are from New York or they're from New Jersey. We could do that. Of course, we don't have New Jersey represented in this Venn diagram, but we're just saying basically when you use this OR, that's a Boolean operator. When you use that OR, it actually means that you're including both students from New York and students from New Jersey. This is where it can get kind of tricky. The OR actually yields usually a larger data set because it doesn't matter if you're in New York or New Jersey, you will be selected. However, on the bottom, the home state must be New York and your major must be geography. So it's not whether you're from New York or whether you're geography. No, you have to be from New York and be a geography major. So your selection is going to be much smaller, most likely. So that's the difference between and or. And is like an intersect. In fact, if I look at this diagram up here, if New York again is A, okay, and geography is B, then this part right here is the only part of that population from the one on the bottom. Unfortunately, we don't have New Jersey on this Venn diagram, but if we did, let's say, for example, we want students from New York or students that are geography majors. If we put an or there, then you would have all the students from New York, so you would be highlighting everyone from A, and then everyone from B. All of these people, these students, would be included in that operation. So SQL, when you're creating either a select by attribute or a definition query, it looks like this. I will show you what this looks like in the lab. Again, we have worked with this already before. There's just some nuances with the language or with some of the formatting. For example, sometimes your fields will be within a bracket, and then sometimes your fields may be with parentheses. So, but all of them basically say, and this is just there all by itself, already part of the dialog box, select from counties where, or whatever your layer you're using. Then you put in here this obviously is a numeric attribute field, population 2010 must be, it looks like, greater than 500,000. Programs must have this interface to help people build the SQL expressions. You could also save. This is something that I used to do when I did GIS in the beginning of my career. I used to save a lot of my queries. But you got to be careful. You're going to be using either your relational or your Boolean operators, and it's case sensitive most of the time. So let's talk a little bit more about Boolean operators. And notice here the and only includes the areas that are both A and B, or includes everything within this diagram. Okay, now these are a little bit more rare on the bottom. You select A, you select B, but you don't want anything that's both A and B. That's what this XOR means. So you're selecting all of this. I'm not an artist. And you're selecting all of this. Okay, and the bottom you can also use not. I want A, but I don't want B. So that means I only want A, and I don't want the part of A that overlaps with B. So I'm only selecting that. Again, you might not find an immediate use for these ones on the bottom, but the ones on the top we're going to look at a lot in this chapter and lab. So this is one of the hardest things that students have with queries. It's really this and versus or. What should I do? Now I've already been through this in a previous lecture slide, so I just want to give you another example. I kind of actually did this example in the other one. So again, if you're using or, you're including both students from New York and students from New Jersey. If you're using and, then you're including students from New York who are geography majors. Okay, so they have to meet both of those criteria with and. You only have to meet one of the criteria with or. If and is used, I'm going to just read right from the PowerPoint. If and is used, then both must be true. If or is used, then either may be true. Keep that in mind. It's very, very important. We're not going to get into all these different types of Boolean operators because we just don't really use them that often, but they are there. We went through the not and we went through the XOR. So just kind of look at this diagram, especially this diagram here again, to make sure you understand at least the difference between and or. Okay, let's test. We have one column on the left and one column on the right. So if we take a look at land use, does it make sense to have land use as residential and land use that's commercial? Think about that. What about this numeric operation down here? If pop 2000 is greater than or equal to 5000, or pop 2000 is less than 9000, what would we get out of that? Actually, we would get all the data, because the or statement means either one must be true. And so all data basically is either greater than or equal to 5000 or less than 9000. So what we find is that the left column is the incorrect one and the right column is the correct one. With most land use databases, you can only have one type of land use per polygon. So you're going to either have residential or commercial. So if you want both of those, then you use an or Boolean operator. If you want to restrict your data so that it's either greater than or equal to 5000, but also less than 9000, you must use an and, because both of these must be true. Basically, this operation down here will yield values 5,000 to 8,999. Okay, that's attribute queries. Let's talk a little bit about spatial queries. You can do, with spatial queries, there's a lot of different possibilities. We could lump those possibilities into three kinds: intersection, containment, and proximity. Does something intersect something else? Are there point data inside something? How far away are you from something? Those are really powerful spatial queries. Okay, so when you do a spatial query, you have to figure out which one is the target layer and which one is the source layer. So let's say we're selecting polygons, which represent aspen stands, and we want to know which ones are intersected by roads. So the target layer says right here, target layer is the one containing the features to be selected. Okay, the source is the one that contains the features, is the one containing the features being compared to. Okay, so we want to select aspen stands. So that means the target layer is our aspen stands, and we're comparing it to the roads layer. Now, when you open up ArcGIS for various spatial queries, you have a lot of different options. And so to keep this a little bit simple, these down here at the bottom are all special cases for intersect. You could have, you can compare one feature to another and see if it's identical. Does it touch the boundary? Is it crossed by it? Is it centroid in it if you're dealing with polygons? Those are all different kinds of intersect operators. Here are a couple more examples. So on the left, we're selecting counties that intersect rivers. But on the right, we're selecting rivers that intersect Texas. And then we have various, what do you call these here? Containment, yeah. I was looking at the Clementini operators, which I never use. So we have contain, okay, or completely contain, are within, or completely within. So this means if it's not completely within, if it's touching a boundary or a border, it won't be, it basically won't be selected. Select counties that contain state capitals. That's kind of interesting. Or select cities that are within counties named Washington. There's a lot of different ways to do this. And one thing you'll learn in a little bit here is we can do both a spatial and an attribute query. We usually do those in sequences, but you can do both of those to make your GIS queries even more powerful. And then we have our proximity. How far away are we something? What is the distance of it? So volcanoes, how many interstates are 100 kilometers within a volcano? That's pretty interesting to know. What I think this is, it looks like Oregon. Oregon here on the right, and this probably is Interstate 5. Okay, so queries in ArcMap. So I mentioned that we do select by attribute and select by location. You could also simply just select things using the mouse. That's what this interactive selection is. You might not think of that as a query, but technically it's a type of query. And with ArcGIS 10, and maybe we had this in 9, you don't just have to select things using a rectangle, which is default. You can use any kind of polygon. You can use a lasso. I've never used a lasso, but maybe that's important. I've used a circle before, and line. Let's say you have, I don't know, a longitude line that you want to use, and instead of finding data to plot that longitude line, you just want to run your cursor along where you know that line is and see which states are intersected by that. Let's say instead of creating a circular feature for something, which might just be temporary, you want to create a specific circle, that has a specific radius, and then select everything that intersects with that. These are different options. We talked about select by attributes. Again, you have to choose which layer you want to select, and you have all these SQL options, whether they're Boolean, and, or they're relational, equals, greater than equals, not equals, etc. Oh, an important thing to note. I mentioned sometimes that there are quotes around the fields. One thing I want to point out is that shapefiles actually use those quotes, but geodatabases use brackets. Because you might be using both types of data, one of the things I do is when I insert a query, first I usually just double click on the field name instead of just typing it out here. That way I don't have to remember whether or not I have to use quotes or brackets. Also, I hit the verify button to make sure that my query language is right. And then this is the select by location dialog box, which I'll show you in lab. You have to have select features from what your target layer is. You have to remember what is your target layer, what layer do I want to select features from. Then you have your source layer, and then you have your spatial operator. All of these that we talked about just recently in previous lecture slides. And then if you are dealing with a distance factor, you can apply a search radius to that. And there's some other interesting nuances, like let's say you already selected capitals for some specific reason, you could use just those selected features. So in the lab we'll get a lot more experience using these. So within a distance is really interesting and powerful, and that's what makes GIS unique compared to other programs that do have queries like Microsoft Access. With this search distance radius and the fact that you can choose whatever unit, it makes finding or using proximity very powerful. And we did examples on intersect. This is what an intersect dialog box might look like. Even with intersect, you could apply a search radius for that, although I don't usually do that. Okay, so I've just talked about selecting. Now, in the past, we've basically did create new selection. But let's say you're doing things iteratively, step by step, and you need to create a new selection, and then maybe you need to go back and add to that current selection. You have that option. Or even more powerful and more common, select from the current selection. Here's an example I like to think about. Let's say I am choosing capitals of states that have a population that's greater than 100,000. Okay, so I've selected all that. But now I need to know what county those selected features reside in. So therefore, I would have those. I could start with by having the capitals, which is a point layer, and only the 100,000 population or greater are highlighted or selected. And then I want to use a select by select by location. Use the select from current selection, and then just do a proximity, intersect, sorry. Then I can do an intersect and say what counties intersect those capital cities. And if I select the select from current selection, it will only select counties that have capitals with a population greater than 100,000. So as you noticed, there are lots of ways to combine these queries. You can, here's another example. Let's say we want cities that are within 50 miles of an earthquake, but are also greater than 500,000. What's the point of that? Well, these are large cities that are prone to earthquakes, so we might want to know where those are. So in lab, there are a couple of ways you can do this. you could do, again, the select from current selection. But what I like to do is actually step by step, if I'm combining queries, I like to create a new layer out of each query. That sort of gives me, it sort of keeps track of what I'm doing, and it makes the querying a little bit easier, so you don't have to remember, do I need to add a current or create a new selection, or do I need to select from the current selection? This way you're just creating new selections all the time. We'll talk more about that in the lab. And this is what I was talking about before. So once you're done with your query, whether it's an intermediate step or the final step, you can go to Selection, right-click on a layer, go to Selection, and then Create Layer from that selected features, and you have just a layer. Now you can go into that and export it into a new database if you want. And that's what this dialog box is showing you. If you want that to be more permanent, because when you create a layer from selected features, you're only creating a layer in that MXD. If it's not saved anywhere as data. So if you want that data to be permanent, you actually have to go to the layer, right click, go down to data, and go down to export data. And it depends on if you want to use, do you want to use the original coordinate system, or do you want to use the one in the data frame? I usually just use the one here unless I'm doing some kind of special project. Now, instead of selecting features, basically so far we have focused on using queries to select features. This is just showing you that you can go into the layer properties, into definition query, and you can restrict what data is showing either in your map or your table by using the same SQL language. This is temporary, okay, but you can make it permanent if you want. So I hope you have a little bit more detailed understanding of queries, and we'll talk much more about these in the lab. Thank you.